Welcome. Glad you made it. Welcome to week 3? We are 20% of the way done through the semester, which is very exciting. And it's weird to only be seeing you once this week. Today we're going to talk about lesson 4, more on sampling, but specifically, we're going to talk a little bit about sampling, but we're looking at observational and experimental studies and trying to understand the difference between those two. Before we get started, though, I want to show you a couple things about Canvas and kind of what's changed. Okay, so here's our class homepage. Just a quick thing, I know a lot of you access the Canvas through your phone. I just want to make sure you know this menu up here, these 3 lines, if you click this, it collapses that menu to give you more screen. Obviously, you're here, so you saw my announcement that we're having to change the Zoom information on a regular basis. I'll be changing it every weekend. So just as a default, just get into the habit of going to the course homepage. And remember, you can click this link and it will open up a web page. You can just click launch meeting because you already have Zoom installed. Also, if your data or your Wi-Fi is sketchy, you can call in. Phone number, I think, will stay the same, but this meeting ID is going to change every time, and you'll see that's the same. But what I wanted to show you was under the modules. Also, while we're here, I want to remind you that you have access to getting help here through NetTutor and the DVC tutoring. So there's a couple things I want to show you. First of all, you know how I've been suggesting to you that after each lesson, you write yourself a little Cliff Notes style summary. One of my students in the other classes does this for herself and has offered to share it with everybody in both of my classes. This is what those look like. So I've added them to each module so that everyone can have access to them. And that's helpful because remember, if you're on a quiz or on a test, there's multiple lessons that are covered. And you want a Cliff Notes way to find the specific information you're looking for. These little summaries narrow down where to look, and then if you need more detailed information, you can go to the worksheet. Ideally, this is something that you make yourself, but not everyone has the time, and not everyone learns best by copying information. Reading this kind of thing, for me, I will remember this, and I can recall it in my memory, but I recall it as a picture, and then I can read what's on the page. That's just how my memory works. It's important for you to find what works best for you. As she completes them, I will be adding them. I put it right above the problem set. It just says lesson whatever summary. To download it, you just click this link up here. I have lesson 3 class activity with Professor Appel. So what I put on this page was links to all the music that we discussed. I added some information about the lawsuit with Marvin Gaye and Pharrell, links to DVC's music industry studies, information about forensic musicologists, Glenn's book, the movie Paul, Tammy showed a couple links of Mr. Appel playing with a couple bands. Like I said, the video will be up soon. And remember, the class videos are here, the live Zoom meetings. Scroll down and you see I have a link that's waiting to be added. Also, just a reminder, if you're unsure what to be doing, I have it set up, so just go through all of those modules. I also want to make sure you know that lesson 6, we're going to cover Wednesday next week. You will need your calculator, that TI 8384, and you'll need it for every single class. Hopefully you have that calculator now. As a way to help get you familiar with your calculator, we have a project. We'll have a number of projects for this class, and they'll be in different formats. This project is in the form of a homework. Remember, it says quiz, but it's homework. As I'm having you do some things on your calculator and tell me what you see. Buttons that you press on the calculator, I've highlighted in green, and that's due on the 13th. So you can get a free calculator for your computer. I have it on my Mac. I'll show you what it looks like. Okay, you can do the graphs on here. You can do all kinds of math. It works just like a calculator, except it's free and it's on your computer. And they're giving this away because of COVID and all. Sorry, we have a couple classmates who are dealing with fires right near their house. And I just want to make sure everybody knows that, I want you to be here, obviously. I want you to learn, but ultimately your health and safety has to absolutely come first. Okay, so please don't put this class in front of being safe and doing what you need to do to keep you and your family safe. Ultimately, that's my bigger concern, is that you're in a good place. Okay, so do whatever it is that you need to do to be okay, honestly. And whether or not you've got fires or just family craziness, or you're just getting mentally overwhelmed for all the stuff that's going on around us. Oh my gosh, it's like it can't stop. 2020, we're over 2020. God. I just want to make sure you all know that, okay? And please don't ever feel like you have to share private information with me. Just tell me I can't be there today. Or if you need help with, I've got access to a lot of resources for you. I can always put you in touch with resources if I don't know the questions or the answers to things. Okay, so just I guess what I'm trying to say is I'm not trying to get into your lives. Ultimately, I want to make sure you're safe. That's the more important thing for me, okay? And just everybody stay safe and do what you need to do to stay healthy physically and mentally. Right now, mentally, we're overwhelmed as well with many, many things going on simultaneously. One of those would be enough to overwhelm a normal person. And now we've got 3 that I can think of offhand without even counting. I think it's really important that we check in with each other to see how we're doing. Just thinking about all the craziness going on, I'm actually getting a little emotional right now. Let's check in with each other. Okay, so let's take 5 minutes, and I'm going to put you in small groups, and not me and Georgie. Me and Georgie are going to stay out of it. And she and I will just chat amongst ourselves. So it's just a private thing with you and a couple other people, just to check in and see how you're doing. And, share however little or however much you feel comfortable with the people that you're with. Okay? Okay, so we'll come back in 5 minutes, folks. So welcome back. I hope that was helpful to have a chance to just kind of check in with each other. Let's talk about the worksheet. I'll just go through the worksheet bit by bit, and we'll take questions by section. All right, and we're going to go through this a little bit quickly if there's no questions, okay, because I want to get to our class activity. We're going to be looking at an actual COVID-19 study that was just completed. So we're going to look at part of that protocol and discuss it. It's a great time to be taking statistics with what's going on right now between the election and the COVID numbers and such. We have statistics happening just all around us. First, I want to mention that the solutions that were on the website, I just made a little small addition, and so I put an updated version on the website for lesson 4. We have 2 types of studies, observational and experiment study. An observational study is something that's just observing or measuring, okay? So this is the way you can think about observational. If you're just looking at something, asking about something, or watching something, then that's an observational study. Whereas in an experiment, you're deliberately applying a treatment. Treatment is deliberately imposed on individuals in order to observe a possible change in the response or the variable being measured. Okay, so that is to say you're manipulating something. And usually in an experiment, there's 2 or more different groups. Okay, so if you see people in the narrative, if you see people were assigned to groups, that's more than likely going to be an experiment. If you see that people were looking at something, asking about something, or watching something, that usually means that it was an observation. Now, mind you, in an experiment, you put people into groups, and then often you look for a change by asking people some questions or observing differences, right? But that's not an observational study. That's just following up for what you had people do and looking for a change. Okay, it's a little subtle difference. Okay, were there any parts on, so questions 1 through, oh, wrong lesson. Questions 1 through 9, I think? 1 through 10, you were asked to read the narrative and determine if it was an observational study or an experimental study. Were there any of those in particular that were confusing, that you weren't able to determine which one it was, or you're not sure how it was determined which one, or why it's an observation or an experiment? Okay, so now that when I share my screen, just so you know, I can see even fewer of you. I literally only see 5 people at a time when I'm sharing my screen. Which, what my husband does is he has a second computer so he can see all people at once. I should start doing that. It's a clever plan. Okay, so just to go through here, you may have noticed that it kind of ping-pongs. Oh no. Okay, 1 second. I have to stop sharing. It stopped responding. Okay, so you may have noticed there's kind of a ping pong, an experiment, observation, experiment, observation, experiment, observation, right? But remember, there's those keywords you can look at. Okay, and I just want to point one thing out. 6 and 7 are very similar. 6 and 7 both deal with sweet potatoes. I just want to point out the difference between those two to make sure everyone's very clear about it in case someone was shy. Okay, so again, I'm looking for those key words to help me determine if it was an experiment or if it was an observation. In number 6, we have 200 students were selected at random, enrolled, and each student of the sample was asked. And that's one of the key words, is that they were asked whether they were ate sweet potatoes or not. Whereas in number 7, they were assigned to one of 2 groups. And one group was asked to do one thing, eat 6 ounces of sweet potatoes, and group 2 was asked to not eat sweet potatoes. And that's how you know it's an experiment, looking for those key words, okay? Both were looking at skin health, so both of them were observing skin health, but one was observing that with after asking people, and one was actually having people do something, assigning them to groups. Then let's talk about, if there's no questions on that, and if you're too shy to ask questions, remember I'll be sticking around after class and you can ask me then. You'll notice that some of those, a lot of these say that like in number 6, students were randomly selected. And in number 7, students were randomly assigned to one of 2 groups. That randomness that it's telling you is a very important thing, because that randomness gives us something special. In an observational study, that randomness, when a sample is chosen at random, the results can be generalized to the population. In a lot of studies, that's what we want to do. We want to be able to say, well, something happened with this group. So because our participants were randomly chosen, we can say that it's likely that same thing is going to happen with the wider population. Okay, so in that YAM study, the observational study with the YAMS, question 6, the participants were randomly chosen, and they were asked, do they eat yams, and their skin was clear or not. The results of that study, the clearer skin with the yams can be generalized to the wider population because the sample was chosen randomly. Okay, and you'll know if the sample is chosen randomly because they will tell you. That's how important it is. You can never assume a sample was randomly chosen. Then in questions 11 through 15, you were asked to determine which of these studies can claim the statistics can be generalized, and estimate which of these studies can claim the statistics can be generalized? Let's talk about that first part. Okay, which of these studies can claim the statistics can be generalized? We just read that they can be generalized to the population if the sample is chosen randomly. So the way to translate that sentence is really what this is asking was the sample randomly chosen?
A sample can be randomly chosen both for an observational study and an experiment, though it may be more difficult with the experiment. But both studies can be random and therefore generalized to the population.
Great question. This generalization only occurs for the observational studies.
Thank you.
Okay, that's a good question. This is strictly for observational studies. And it's extremely rare that you'll see an experiment that is randomly chosen participants, because the experiments have different protocols. If you're going to do something to somebody, they have to consent, and there's all of these different things that need to occur. But if you're just observing some things, it's easy to randomly choose people. The question we're really asking here is, for example, 2 is, was the sample randomly chosen? Because if yes, then we can generalize. Okay, so we're just going to look through each of these and find where they talk about the sample and determine if it was randomly chosen. And I apologize, I just realized the solutions that I put on Canvas are an older version, and you'll notice that a lot because I kind of refined the worksheets a little bit, making them more clear for you folks this semester, but the numbers haven't changed. There's just like here, I call it example 2, but if you look on my solutions, I didn't have it called example 2. So that's the only difference. Looking through here, so here over 18,000 people voted. Okay, a website asked visitors to vote. Is that a random selection? No. All right, what about this next one? A student doing a statistics project uses her friends as a sample. Is that a random selection? No. Fire safety officer checks 32 randomly selected classrooms for fire code violations. Was that randomly selected? Yes. So this one does generalize. And 14, a survey given to students asks if they should stay open later. Was that randomly given to people? No. A public park in Concord, 35 people with dogs were asked how many minutes per day they spend. Do you see the word random in there? No. So this one also is no. So only one we're told is randomly selected, and so that's the only one that generalizes. So let's go to the next part. It's a generalization, but we cannot claim a cause and effect. We cannot, oh, whoops, I thought that was a highlighter. We cannot claim a cause and effect relationship. We can never prove anything is true because we are all different people. People behave differently. We can never claim something's going to happen with 100% of people. What we use are words like associated with, links to, strong link to. So that's as close as we can get. Part of that reason is lurking variables, or also known as confounding variables. And these are things that the researcher has no control over. We can say linked to depression, but we can't say causes depression because there's always other things happening. Genetics, background, living situation, lots of things that are not part of the study. So then on the next part, for questions 16, 17, and 18, I had asked you to come up with some lurking or confounding variables for these ones. There are a million different answers to these different questions. I just put on my solutions the things that I thought of initially, okay? I'm not asking you to make up a huge laundry list, just give a few things for thinking about confounding variables, or just 2 or 3 things that you can think of. We all have different experiences, backgrounds, we all are going to see things differently, and we all know, please do not take what I said as being the only answers or the right answers, especially for these 3 here. Okay, so let's talk about experiments.